My name's Lynn Rothschild. I'm a senior scientist at NASA Ames Research Center, and I'm also an adjunct professor at Brown University, which is where we are today. So what we're covering today is the iGEM program, which stands for International Genetically Engineered Machine Competition. And what it is the premier synthetic biology competition for mostly undergraduates from around the world. This is actually a brilliant thing for NASA because what we've done is taken students who are very bright, very creative, and very passionate and had them focus on some of our big problems at NASA. And we've tackled problems such as how you actually set up synthetic biology-enabled human Mars colony, because all these projects have to involve synthetic biology as the enabling technology. We've done a year that's focused on astrobiology. How can you use synthetic biology to answer some of the big questions in astrobiology? Are we alone? Where do we come from? Where are we going? And then we've done some work around different exploration platforms. For example, I challenged the students one year to make a biodegradable drone, and another year to make a bio balloon for exploration. Or what about self-folding origami?
I looked at what are the biggest problems that I think are facing humanity and where are the opportunities for technological change or things that can improve humanity. And two of those things happen to be AI/software technologies, as well as genetic engineering and biological engineering. I primarily worked on mission architecture, things like on-Earth manufacturing, to picking launch sites for a mission, to off-planet landing sites, and then how you actually implement and inhabit another planet.
It's a really unique way to conduct synthetic biology research that makes you examine not only the research itself, but the other applications of it, like the ethical, legal, societal implications, and also lets you take control of your project and design your own idea and execute it till the end.
It's very self-driven, so instead of our advisor giving us a project description, it's us as a team coming up with our own goals and how we're going to meet them.
This year I'm very excited because what we've done is challenge the students to use fungal mycelia, this sort of thread-like structures that a mushroom has underground, to actually build structures. For example, a habitat on Mars. In fact, I have some pieces of some of the stuff that they made this summer right here. And I realize it looks a little bit like a dried piece of toast that's been left out on the counter for a month. But this is actually particles of sawdust that are held together with fungal mycelia. This particular piece feels a little squishy, sort of like styrofoam, but if you bake it, you can make very hard structures that are like plywood or particle board. In fact, the students made a stool that you can sit on this summer. As a practicing scientist, you don't sit there and wait for someone to hand you a test tube. You have to come up with your own ideas and then develop a strategy for doing the experiment.
Yeah, it's a great experience. It's a lot of work for sure, but the truth is that you have a level of ownership over your projects that you would see more commonly at the PhD level than at the undergrad level.
Know that not everything will work out in the lab. Even if you follow every single protocol, every single step that you should, sometimes things don't just work out. So always just account for that time, because you're doing a lot in one summer, especially considering that all of this research is what you want to do.
If you put in the effort, you can definitely learn a lot and then take what you have learned from this to help you in your career moving forward.
I could go on and on about every project we've done, but the point is that NASA is hugely excited because we've got these very creative students applying novel technologies to novel problems, and I've actually come to believe that synthetic biology is going to be the enabling technology to really understand some of our big questions like the origin of life on the science side, but also on the exploration side, that we'll never be able to live off planet if we don't take advantage of synthetic biology.